Kia ora Year 12, here are the last two questions from the 2014 integration paper. So the first one is a Newton's law of cooling question about an oven tray, very exciting context. And the second one is a straight out integration that looks like it might be bad, but is actually really easy for a merit question. So let's do the Newton's law of cooling one first. So as usual, reading carefully, the oven tray is taken from a hot oven and placed in a room that conveniently has a constant temperature of 20 degrees Celsius. The rate at which the temperature of the oven tray changes at any instant is proportional to the difference between the temperature of the tray and the room temperature at that instant, and we know that that's always 20. Write a DE that models this situation, and then we have to figure out if the oven tray starts off at 220 degrees, the temperature drops to 100 after 3 minutes, what will the temperature be after a further 2 minutes? So that means after 5 minutes, right? Really easy to miss that if you are in too big a hurry, and then you will waste a whole lot of time trying to fix it later. So let's start and write the DE. Okay, so I'm going to use big T for temperature. So dt by dt is equal to K, the constant of proportionality. So it's proportional to the gap between the oven tray temperature and the room temperature, which is 20. Okay, so the next thing we've got to do is separate the variables and integrate. So getting all of my T stuff over to one side, all of my big T stuff, and then everything else here. And this pattern should be feeling really, really familiar by now. So integrating the left-hand side gives me the natural log of the absolute value minus 20. And over here I get E, gives me KT plus C. T minus 20 is equal to E to the KT plus C. T minus 20 is equal to AE to the KT. T is equal to 20 plus AE to the KT. Now, if you remember in class when we did differential equations, I gave you out that really nice book from Mr. Vaughan about applied DEs, and he goes through this one beautifully. This is a set piece of integration that comes up all the time. So you want to be able to do this bit through here like you're just adding up 2 plus 2. It should feel really, really familiar. What we're going to do next is we're going to start substituting to figure out the value of A and then to figure out the value of K. Okay, where are we? So we know that at T equals 0, big T is equal to 220. So 220 is equal to 20 plus A E to the 0. A is equal to 200. Now you might know that off by heart, but I want you to always show that step, please, because it's good working. Have I done that right? I think so. Yeah, so we've got T is equal to 20 plus 200 E to the KT. And what do we know next? Well, we know that after 3 minutes, the temperatures drop to 100 degrees. So we'll substitute in 3 here, so we get E to the 3K. Just being careful with this, we get 80 divided by 200 is equal to E to the 3K. We're going to take logs of both sides. So we get the natural log of 0.4 is equal to 3K. K is equal to 1/3 times the natural log of 0.4. That's going to be a negative number. That works out to be negative 0.3054. So let's just have a look at what that shows us for our equation and also why it makes sense. Okay, so that shows me if I just quickly, you're not asked to do this obviously, but it's a good idea to do it. And you certainly could be asked to do it in the A-level exam. If we want to graph that, what have we got? Well, we've got a starting point up here of 220, and we've got a horizontal asymptote at 20, and we've got a decay curve like that. And so after 5 minutes, we now have to work out what the temperature is going to be. So I'm going to substitute in T equals 5. So T equals 20 plus 200 E to the negative 0.3054 times 5. That gives me 63.4 0.43 degrees Celsius after 5 days. I don't mean 5 days, I mean 5 minutes. So there you go, that's the first one done. Now the second one is much, much faster. And this is it here. It looks bad, but that's just because we have to rewrite the denominator with a fractional power. So we've got the integral between 9 and 4 of 18x to the power of -3/2 dx. So all we have to do here is be really careful when we integrate that we do integrate and we don't differentiate. So my coefficient here is going to be 18 times -2/1, right? So the reciprocal of that, evaluated at 9 and 4. So that gives me -36 times that, if you want to bring that constant out. So -36 times 1/3 minus 1/2. -36 times 2/6 minus 3/6. I know some of you will do that on your calculator. -36 times -1/6, which gives me a final answer of 6. So there you go, that's those 6 questions done. Hope you've enjoyed watching these. Probably will be another little surprise test sometime soon. Have a good weekend.